Hi, my name is Liam.
My name is Ethan.
My name is Elliot.
And this is Brandon.
And in this video, we'll be learning about ionic bonds.
So what exactly are ionic bonds? Let's break it down. Ionic bonds usually happens when one atom transfers electrons to another. This usually happens between metals and nonmetals. Metals tend to lose one or more electrons, which results in it becoming a positively charged ion. Nonmetals usually gain one or more electrons to be stable, and this results in them in being a negatively charged ion. These two negatively charged atoms attract each other and create a strong bond. But why are ionic compounds so important? Well, they play a crucial role in chemistry in our everyday lives. For instance, table salt, or also known as sodium chloride, is a classic example of an ionic compound. It's essential for our health, helping to regulate fluids in our bodies. Ionic compounds are also found in many other substances, like baking soda and even some medicines. They contribute to the properties of these compounds, which are high melting and boiling points. These properties help create a stable compound and becomes very useful in many different applications. Whether it's in the food we eat or the products we use, ionic compounds are everywhere. They're a fundamental part of modern chemistry that helps us to understand how different substances react.
First, let's define what an ionic bond is. An ionic bond is a type of chemical bond that occurs when one atom transfers a valence electron to another, resulting in a strong attraction between the two oppositely charged ions. Now, let's talk about how these bonds form, especially between metals and nonmetals. In ionic bonding, the metal, which has a low electronegativity, loses one or more electrons. When it loses electrons, it becomes a positively charged ion, or a cation. On the other hand, a nonmetal, which has a higher electronegativity, gains these electrons, becoming a negatively charged ion called an anion. This transfer happens because of the octet rule, a fundamental principle in chemistry. The octet rule states that an atom tends to gain, lose, or share electrons to achieve a full outer shell of 8 electrons. By transferring electrons, both the metal and the nonmetal can achieve a stable electron configuration. For example, sodium, a metal, has 1 electron in its outer shell. It will lose that electron to achieve a stable configuration. Once it loses that electron, it becomes a sodium cation. Chlorine, a nonmetal, has 7 electrons in its outer shell. By gaining that electron, it fills its outer shell, becoming a chlorine anion. These oppositely charged ions attract each other, forming a strong ionic bond. One characteristic of an ionic bond is that they are usually soluble in water, which means that they dissolve as water molecules surround and separate the ions. In summary, ionic bonds are formed when metals transfer electrons to nonmetals, creating a stable electron configuration for both atoms. The resulting oppositely charged ions are held together by strong electrostatic forces, leading to the unique properties of ionic compounds. And that's the essence of how ionic bonds form, through the transfer of electrons between metals and nonmetals, creating oppositely charged ions that attract each other.
Ionic bonding occurs when electrons are transferred between atoms, creating oppositely charged ions that attract each other. Here's how it works. Metals, like sodium, have a few electrons in their outer shell, which they lose easily to achieve a stable electron configuration. When sodium loses an electron, it becomes a positively charged ion or cation. On the other hand, nonmetals like chlorine need extra electrons to fill their outer shell. Chlorine gains the electron sodium lost, becoming a negatively charged ion, or an anion. This transfer of electrons creates an attraction between the positively charged sodium ion and a negatively charged chloride ion, forming the ionic bond. Together, they create a compound like sodium chloride or table salt. In summary, ionic bonding is all about the transfer of electrons, creating cations and anions that attract each other to form stable compounds.
There are a few distinguishing properties of ionic compounds. This includes high melting points, which means that they melt at a higher temperature. For example, an ionic compound can't melt at a low degree, like 50 degrees. It'll need to go to close to around 200 degrees to actually melt. This also goes for their boiling points, since it takes a high temperature for ionic bonds to boil. There's a high electrical conductivity since the ions can move freely in an ionic bond.
Let's review what we learned about ionic bonds. Ionic bonds form when atoms transfer valence electrons to achieve stability by following the octet rule. This basically means that atoms have to gain 8 valence electrons in their outermost shell to achieve stability, like noble gases. Here's how it works. Atoms like sodium have a low ionization energy, which is the energy required to remove valence electrons from that atom. This makes it a lot easier for them to lose electrons. On the other hand, nonmetals like chlorine have a high electronegativity, which is their ability to attract valence electrons from other atoms. This makes them great at gaining electrons to fulfill that octet rule. When electrons transfer, positive cations and negative anions are formed. These two oppositely charged ions form a strong ionic bond. These ionic bonds have unique properties such as a high melting and boiling point, which makes them very useful in our everyday lives in modern day chemistry. Thank you guys for watching the video, and I hope you guys enjoyed and learned a lot about ionic bonds today.